For this investigation, we are going to need to make sure that we have a control group. And the control group is going to be, in this case, the potato and the banana that hasn't been dipped into any type of solution. So we're able to monitor the length of time that it takes for the potato and the banana to go brown. It's important to know that when the skin of a fruit or a vegetable has been removed, the air, so the oxygen which is in the air, that tends to make the fruit or the vegetable go brown, and this process is called oxidation. Oxidation is a chain reaction that occurs only in the presence of oxygen. So if you've ever noticed when you've cut an apple in half and just left it on the side, it might go brown. And that is simply because the oxygen in the air has touched the fruit, and it encourages it, or it makes it break down so that it's easy for the body to digest. But if it is left out for too long and not kept in the right storage places, it can go off. Here, Soraya's about to test the pH balance of the liquids that we are going to use in our experiment. So on the left-hand side, you'll see that she's testing the lemon juice with the pH indicator. And then the one on the right-hand side is salt water. So water was mixed with salt and stirred till the salt was had dissolved. So as you can see, when she picks up the lemon juice, she holds it against the spectrum, and as you can see, it's mainly closer to the reds and the oranges, which means that the lemon juice is highly acidic. If it was closer to the purples, then it would be an alkaline solution. And as you can see, the salt water is closer to the yellow and the green, so therefore, going back to the control group that wasn't dipped in any mixture, we can see that the banana has slightly gone brown, but the potato hasn't changed yet. In this section, Soraya has begun to peel a different potato. So we decided not to use the potato that we used before because that sample had already begun the oxidation process because the skin had been removed. So we used another potato to try and make sure that the test was fair. So she's sliced a few slices of potato and popped it into the lemon juice. And then she's also sliced some more of the potato and popped those slices into the salt water. She'll do the same with the banana, and then she'll place it on a chart so that we're able to identify which vegetable and fruit had been dipped in what. So each group, the control groups and the groups that had been dipped into the solutions, will be given 20 minutes to have a look and see what happens to them. So as you can see from the control group, and sorry about the focus, but the banana has gone significantly brown from the center and around the edges, but the potato still hasn't gone brown yet. I feel like the potato would have needed much more time. This is the chart that we've used to put all the potatoes and the bananas on. This is 10 minutes later. 20 minutes later, and you can see that the bananas from the control group have gone broken down much more. The process of oxidation has made the brown color come through, and those pieces are breaking down more. So what Soraya's done here is picked up the banana, and she's about to put them next to the salt water and the lemon juice to compare how they are. So 20 minutes later, you can tell that the banana is not as brown as the one from the control group. And the same goes for the one from the lemon juice. So from this experiment, we was able to see that the salt water and the lemon juice slowed down and stopped the process of oxidation. The potatoes didn't work so well. Maybe you can try this experiment at home with an apple.